Okay, so in the last video, we did some slope analysis of our surface to determine, which bricks had a high runoff and different slopes, and we could adjust those visualizations a little bit differently. So now what we can do is maybe we want to have some analysis per other geometry. So I'm going to draw a couple of curves, and we can use those to analyze uh, the relationship of the bricks to those curves. So second top view, I'm going to draw a couple curves. I'm going to draw maybe a path through the center of this. I'm going to also draw, let's say we had like a building on the site. Okay, so I'm going to bring these two curves in separately. Okay. So what I'm going to do is get another copy of these bricks and another copy of their center points. So the bricks are coming from here. Keep that hidden. And the center points are coming from here. Make that hidden. Organize this a little bit. Okay, so something we can do is we can say get the distance from these bricks to one of these curves. Take these previews off. So I can get curve closest point. So I have the curve, I have these points, and it will give me the distance from those points to that curve. So I can see those here, there's distance. And I can get the bounds, so I know what's the highest and lowest distance that we have. Suppose it goes from 2 feet to roughly 400 feet. So let's remap those. So this distance will remap from 0 to 1 in this case. Okay, now I can say that if any of these distances are smaller, say if they're smaller than 0.5, so that would represent basically like 50%, then we can sort of selectively determine which bricks those are with the dispatch. So we have all of these surfaces, and we're going to dispatch them if they're smaller. And then maybe we can do a custom preview of this. So I'll get the swatch layer. We'll say okay, all the ones that are inside and outside, and maybe I'll make these darker gray. Okay, so you can see that these are 50% of the distance, and I can make that closer. Closer to what would be that path through that. It sort of cuts across that in different ways. I can also just use the distance. So if I knew that that bounds was between 2 and 4, I could set that to a specific number if it was smaller than 200, but it's a little easier to represent it in terms of percentage. Okay, so we have that. You can see it makes a pretty specific path. You could also set that with respect to this other one, and it'll sort of draw all the bricks that are within this distance. So we can use those sort of interchangeably. But what if you wanted to have a little more control over that? So that's a pretty defined line. You can make it bigger or smaller. But what if you wanted to feather that out a little bit, make more of a random edge or a softer edge to those bricks? So I want to try to implement some randomness to that. That would allow me to have more control over that. So I'm going to take this distance over here. I'm going to get the length of that list length. It'll tell me that I have roughly 2,800 bricks. And then I'm going to make a random number for each one of these. So it's going to be between 0 and 1. I'm going to make 2,800 random numbers between 0 and 1. And then what I'm going to do is I'm going to add that number to our remapped numbers. So now I have a number that's between 0 and 1, and another number that's randomly between 0 and 1. So when I add those together, I have the potential of being between 0 and 2. So if this one is now smaller, you can see that it's still everything along that path, but I have a little more randomness. Obviously, that randomness has also caused a lot of these to disappear in there, so it's not quite the control that we wanted. I want to also give it more control over that. So if I make this smaller or bigger, just like before, it makes that path wider and smaller. But I think this random number is actually a little too strong. I want to see more of that path a little bit more. So what I'll do is, instead of saying that this is going to remap from 0 to 1, I actually want it to be a higher number. So I'm going to take this. I'm going to construct a domain. Say that instead of 0 to 1, I'm going to go 0 to 10. So we can organize this a little better so you can read it. So 0, now this number is going to be between 0 and 10, and this number is going to be between 0 and 1. So this number will be between 0 and 11, but predominantly driven by its distance, not by this random number. And so if this number is smaller than this, not a very big number, so not a lot of that is happening, I'll make something to the full number. I'm going to have a little more control over that. So already this edge is kind of feathering out a little bit more. You can see how that works. Something else I can do is instead of using this number, I'm going to add this number, 10, and 1. So that represents the possible 0, 0 to 10, and then this possible one other one that I have. So this is the full size number. And then I'm going to multiply it by some percentage. So it's a little hard to tell with 2.3 what that actually means. But if I set that to 0.5, I know that I have a ratio instead of 0.5 is 50%. So I can adjust this somewhere and get something like that. And if I lower this 10 value, then I'm basically saying that that randomized number becomes more prominent. And you can see that sort of feather in and out when I do that. So what this is basically allowing me to do is have some control over the articulation of these bricks through this curvature, but then also control that through this randomized value. And if I plug this other one into it, you can see that that can happen along that as well. And this is happening in 3D. So this point up here is further away from this. It's not just happening in plans. You can see how this corner, as it gets higher, is also getting further away, and you have less bricks that are dark gray. So I'm going to group these together. I'm going to call this distance and use that as a criteria as well.